Okay, now we will look at the third learning outcome, which focuses on events and probabilities. Okay, so I would like to introduce some terms to you. Probability is chance of an event occurring in mathematical terms. Sample space is set of all possible outcomes of a probability experiment. Okay, this is a sample of a tree diagram. Definitely many of you have drew it in high school. Okay, if you're not, you can ask me about tree diagram in your next week's tutorial session. An event consists of set of outcomes of a probability experiment. That means what happened, the outcome is considered the event in mathematical terms for probability. So next, these are some basic probability rules, which I believe many of you are aware of it. Um, the probability value of an event has to be between 0 or 1. If an event occurs, um, and it's certain that it occurs, the probability is maximum 1. And if an event cannot occur, there's no possibility of it at all occurring, that means the probability is 0. So that's why your lowest value of probability possible is 0 and the highest is only 1. You can't even have 1.0001. Okay, and the sum of probability of all outcomes in a sample space is 1. For example, if you have a dice, it has 6 sides. So each time when you roll the dice, you should only have 1 out of 6 possible outcome of number 1 to 6. So the sum here means the sum of getting number 1 is 1 over 6, number 2 is 1 over 6, number 3, 4, 5, 6 is 1 over 6 each. So when you add 1 over 6 times for 1, 3, 2, 4, 1, 2, 3, 4, 5, 6. So 1 over 6 times 6 is equals to 1. That means the sum of probability of all outcomes in a sample space for that particular event of rolling the die is 1. Another example is if you toss a coin, there's only two possibility, which is head or tail. Possibility of getting of head is 1 and possibility getting of the tail is half. So half plus half is 1. So sum of probability of all outcomes which is possible in one sample space is only maximum 1. So you have to really understand these probability rules. Next, I would like to speak about complementary events. So complementary events are simply set of outcomes in the sample that are not included in the outcomes of an event. So because they complement an event, right? So for example, you denote it as probability of event with a bar. So these are complementary events. Is obviously what is not included in the outcome. So therefore is one takeaway probability of the event occurring. And by rearranging this, probability of an event occurring and not occurring should sum to 1. Okay, so how normal probability that we always calculate is actually the empirical probability, which is f over n, and f here represents the frequency for the particular class, and also n represents the total frequency in the distribution of the probability. So this is what you have been calculating all this while, and it's called the empirical probability. The next learning outcome will actually discuss the mutually exclusive events. So it's important for you to understand what is meant by mutually exclusive event. So two events are mutually exclusive or not connected or disjoint if they cannot occur at the same time. So for example, if you want to select a person with type A blood randomly, and you also want to select a person with type blood O randomly, these two events cannot occur at the same time, simply because a human only has one type of blood. So logically, this event cannot occur and they are not connected. they are disjoint, so they are mutually exclusive on their own. Yeah, so therefore first example is a one example of mutually exclusive event. The second example is when you want to randomly select a person under 21 years of age and also randomly select a person above 30. So obviously when you announce this, say in a crowd of 100 people, you cannot have two people or cannot even have one person who is under 21 and also above 30 at the same time. So these two events are mutually exclusive events, right? They are not joined, they are disjoint. Yeah. Next, I would like to highlight the additional rule in probability calculations. When two events A and B are mutually exclusive, the probability A or B, or pay attention to the word or, okay, will occur is when there's P, A or B. Yeah, because they can't occur together, so only one can occur. You add the probability of each individual event. Okay. Addition rule number 2, when two events A and B are not mutually exclusive, the probability A or B will occur is, means they are not mutually exclusive. It's sum of probability A, sum of probability B, event B, take away sum of A and B, right? So please pay attention about the addition rule. Okay. Later at the end, we will have a example of question which actually normally probability questions normally combine all the probability package together, right? So we will have the question at the end of the probability introduction here. And the fifth learning outcome here explains about independent and conditional events. So the first multiplication, just now we looked at addition rule, now we will look at the multiplication rule. Two events are independent. Probability of both occurring is A and B is, when you say and, you actually multiply the probability of each individual event, like here PA and PB. So two events A and B are independent if the fact that A occurs does not affect the probability of B occurring. So example, event A, tossing of a coin, and event B, rolling of a dice. So these two events don't depend on each other, they are independent, right? So in order for the probability calculations, you can actually apply this multiplication rule 1. Next, I'll introduce to you multiplication rule 2. When two events are dependent, the probability of both occurring PA and B, you add PA and PB. So pay attention whether the events are dependent, independent, mutually exclusive. So these three terms are very important here. So for example, two events A and B are dependent when the outcome of the first event affects the outcome of the second event. So for example, when you select a ball from a basket, say you have a few colored balls there, you select a ball from the basket, and then you select the next ball or the second ball without replacing the ball that you took out earlier. So it will affect the probability calculation here. So therefore this event is dependent on, the second event is dependent on the first event. And second example, getting high grades and getting a scholarship. These two are totally dependent. Most of the time you get a scholarship if you actually get high grades. So that these two events are highly dependent on each other. Next, the third type of probability is conditional probability. So the conditional probability here, for example, when event B in relationship to an event A is defined as the probability that event B occurs after event A has already occurred. So you must make sure one event occurs before or after the other. Okay, so and then you can use this formula to do the conditional probability calculation. For example, we will look at one example. Two dice are thrown. Draw a tree diagram to show all the totals when the dice are added. Here simply means when you throw two dice, say you get 1 and 3, so you add 1 and 3. Okay. For part B, based on the diagram we drew, we need to determine all this. Okay. Sample of S, probability of getting 7, probability of getting 4. And for part C, we need to find a probability. They're asking you whether probability of getting 7 and 4 are independent events. So we will look into it after this. And use a two-way table to find all these probabilities stated. Okay. The first type, the probability of getting a sum of 7 on the first row and first row of the two dice, or a sum of 4 on the second row. So this gives you the keyword or. The probability of getting a sum of 7 on the first row and of the two dice, and a sum of 4 on the second row. Which is greater, the probability of getting 7 or a 4, or the probability of getting a 5 and a 4? Okay, so let's have a look at this. So easier way, instead of using a tree diagram, all right, you can use a two-way table. Okay, just an introduction. Yeah, two-way tables are more effective. Okay, so for example, dice 1, dice 2. So dice 1, you throw 1 to 6, dice 2 also has 1 to 6. So this shows that when you throw dice 1 and you get 1, there's a probability of getting 1, 2, 3, 4, 5, 6. Right? So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, and so on. So for example, when you throw the first dice, you get a 5. An example, second dice is a 3, so it's automatically 5 plus 3 equals to 8. Right, so this is how a two-way table works. You put what plus here because you add the outcome that you get for both the dice. All right. So for the first question for part B, there are 36 outcomes. So you got 36 outcomes based on this diagram here. You see, of course you throw dice, you have 6 numbers, and each time you have another 6 outcomes, so 6 times 6 is 36. Okay, and it's proven by this table, and 6 of the outcomes will give you 7, so you can check here 1, 2, 3, 4, 5, 6. Yeah, there are 6 possible 7 outcomes of getting a total number of 7. All right, so the probability is 6 out of 36, which you can simplify to 1 out of 6. And the next one, there are 3 of the outcomes that will give you 4 as a total. All right, how do you get that? You have a look here, there's a 4 here, 4 here, 4 here. So there are 1, 2, 3. So 3 out of total outcomes, which are 36. So your probability is 1 out of 12. So part C, the question says the probability of getting a sum of 7 on the first row of 2 dice, right? That is actually 1 out of 6. And the probability of getting a sum of 4, which is actually 1 out of 12. Are they independent events? So they are independent events because getting a 7 and getting a 4, it is not dependent on each other. Yeah, so throwing the first dice and the second die doesn't affect each other. So in this case, getting a sum of 7 and 4 are independent events. For part D, the question said probability of getting 7 or 4 and 7 and 4. So you need to do the calculation first. The question asks which is greater. Okay, so you calculate the probability of getting 7 or 4. Remember the term or. So the term or requires you to actually add the probability, individual probability, which you got in part B, 1 over 6 plus 1 out of 12. And for the second one, 7 and 4, so you multiply. All right, and they are independent events as well. So you multiply, you get 1 out of 72. So compare both of this. The probability of getting a 7 or a 4 is greater than getting a 7 and a 4. So obviously 1 over 4 is greater than 1 over 72 by comparison. Okay.